This video is about teaching more efficiently with technology, our Math 8 story. Previously, I showed you guys a model called the SAMR model that describes the different levels of integration for technology in the classroom. Substitution and augmentation are both the easiest and also the least meaningful, although can help you teach more efficiently. This video is more about the modification and redefinition level. Obviously, the first thing we do as teachers is we sit down and we take a look at the state standards so that we know exactly what we need to be teaching to our students. I'm going to show you the 4 standards in our Unit 2. So as we read these in team and kind of dissected them, our final takeaways were that we need to have students try each transformation and make observations about their property changes, connect the property changes to changes in the coordinates, and describe a sequence that would prove congruence or similarity between 2 figures. So we asked ourselves, how do we get students to understand sequences and all the property changes therein? So when our team originally created this unit, our previous approach was to take each transformation one by one and have students perform each transformation by hand. This was going to be great for our hands-on learners. It was going to reinforce spatial thinking and awareness. And we also were, after each new transformation was learned, incorporate a quote-unquote sequence days that would build them together so they would start to see how these transformations could be combined into a sequence. And it kind of would bookmark our unit of study so kids had a mental picture of where we were headed with the unit. However, we definitely ran into some problems with our original philosophy or our original idea with this unit. The first problem we came across was that the recommended number of days for this unit of study is supposed to be between 12 and 15 days. Taking a look at our pacing, we were at 24 days. So clearly our approach was taking longer, and originally we figured our students need remediation on most topics, so this isn't uncommon. However, that's a lot longer. That's about 2 weeks more of instruction. We also encountered that student mistakes with doing it by hand made it difficult for students to see the property changes that they needed to see. We had to deal with broken and loose compasses when we were doing rotations by hand, and that just became a nightmare where we didn't have enough compasses, kids are waiting on each other. And then also we noticed that in Math 2, students learn how to do these transformations by hand specifically. That's a Math 2 standard. And so maybe we needed to start thinking outside the box because our standards don't call that out. So the critical question became, how can we get students to understand the property changes as well as work through sequences of transformations without teaching them how to do each transformation by hand? And can technology help us? So just to showcase the change in our instruction from beginning to end of this video, I am providing you with an abbreviated version of our guided notes that we used in this unit. Again, our old approach was to do everything by hand, and so it was very much paper and pencil, which we absolutely support. Paper and pencil is very meaningful in itself, but it was all paper and pencil. We were running into those problems that I previously mentioned, and so anyways, consider this a before glimpse. So then, through our own professional development, we knew that we wanted to integrate technology more into our math curriculum, and we started looking at some of the activities that Desmos has for this unit of study. We started specifically to look at how does Desmos build conceptual understanding by using their technology platform. What are some things that students can do using technology or on these activities that they can't do on paper and pencil? And does it achieve the same end for our standards? Do we still build the same understanding without sacrificing anything else. One advantage we saw immediately is that students could practice multiple examples back to back more quickly. And in doing so, we're able to make those observations about property changes that maybe they were a bit too fatigued to kind of see it as plainly before when they were doing everything by hand. And we also saw that students were much less concerned with the mechanics of doing it by hand, and they were more focused on that big picture or on that conceptual understanding that the standards really speak to. So next, I'm providing you a document, and this is a running list of technology activities that are applicable to this unit of study. We did not use all of these. This is kind of a running list similar to the one that we're going to revisit next year when we teach this unit again and revise our unit. However, on the list, you'll notice that I've put asterisks near some of the links, and those links are activities that we created. So it wasn't just about finding activities on the internet that can do what we wanted to do. We also wanted to build our students' understanding in a way that we knew that they could relate to. So using Desmos again, where teachers can create their own custom activities, we started to investigate some of what they call the labs. So if you contact Desmos, they will give you permissions in your account that aren't readily available to everybody. And we were able to kind of use those tools to create our own custom activities that students could relate to and that we knew would build the understanding that we needed them to build. So rather than play a game to understand, it was a more dynamic version of the introduction to new material. So take a click on that link and you'll see a list that populates. So even after lightly starting to integrate this technology and kind of create our own learning activities, we saw some immediate results. So first and foremost, our own teaching transformed. Our teaching of dilations and rotations in particular changed because we started focusing more on the center of rotation and the point of dilation. This mimicked exactly the same way that we focus on the line of reflection when we're teaching reflections, so it makes sense. But by focusing on these same critical ideas across the board, we opened up a whole new way of teaching sequences, which is the much more complex standard that we needed to address. We needed to get them up to sequences without having them do it by hand, and that was our main concern. So we actually opened up a whole new way of teaching sequences because we ourselves, through the technology, observed different ways to accomplish the same exact problems. So as a result, sequences became much more accessible to our students, and our students were able to learn via technology the same way or even better than they were by hand originally.